Hello, good morning. Myself Sanjay Gaikwad. Today we want to discuss FY paper second, modern physics. Unit number second. Topic name is radioactivity. These are some symbols regarding the radioactive materials. We know that this is the symbol of radioactive material. This is the symbol of the atom, where the atom has a diameter 10 raised to minus 10 meter, and inside the nucleus, inside the atom, there is a heavy mass is there, that is called as the nucleus. The size of the nucleus is in the range of the 5 into 10 raised to minus 15 meter, or you can say that femtometer, 5 femtometer, and this is the radius of the atom is 1 angstrom nearly, and approximately 5 femtometer is the diameter of the, or sorry, radius of the nucleus. And inside the nucleus, there is the proton neutrons is there, and surrounding to that, the electrons are revolving around the nucleus. Now we are going to discuss about the details of the radioactivity. Radioactivity. In this topic, the content of the radioactivity is the radioactive disintegration concept of natural and artificial radioactivity, properties of the radioactive materials, sorry, radioactivity, radiation, just like alpha, beta, gamma radiation, and some laws, that is laws of radioactive decay, half-life period, and other things. The outcomes of this presentation is that we understand the nucleus and also the nuclear phenomena, radioactivity, and its application of radioactivity. Introduction. The radioactivity is the phenomena of spontaneous emission of radiation from the radioactive substance. It's called as the radioactivity. Generally, this spontaneous important word, it is a natural phenomenon. Due to the unstable of the nucleus, there is a spontaneous emission of radiation takes place, and this phenomenon is called as the radioactivity. The spontaneous emission of the radiation from the radioactive substance is known as the radioactivity. It is a reversible, self-disintegrating, and spontaneous nuclear phenomena. It takes place naturally, and therefore it is a self-disintegrating phenomenon. First, some materials are or elements are discovered by some scientists, and these are the following scientists. Becquerel in 1896, he discovered uranium. Marie Curie and Pierre Curie, they discovered the thorium, polonium, radium, and for that, Dabran and Giesel in 1899 discovered the actinium radioactive material, and Rutherford, who discovered the alpha beta radiations, Willard in 1909 gamma rays. Now, this is the one of the famous uh, pair, Marie Curie and Pierre Curie. Marie Curie and Pierre Curie got the Nobel Prize for the new element thorium and radium, sorry, polonium and radium, and they got the Nobel Prize for the chemistry for determination of the radioactive elements, new elements, and also for the Marie Curie has got again one of the Nobel Prize for the radioactivity phenomena in 1911. Next is a well-known famous diagram of the radioactive disintegration, where there is a lead box. Lead box has the property to absorb the radiation, alpha, beta, gamma radiation, where R is radioactive material. P, see, this is a P. This is shows that the photographic plate on which the alpha, beta, gamma radiations are incident on the photographic plate, and it gives the path of the incident particles. Third, next one is B. B XS incident shows that there is a perpendicular to this plane. The magnetic field acts on that, and this is the P1, P2 shows there is the application of the electric field. When radioactive material is kept in this block, lead block, and there the radiations are emitted from this block because of this opening, and other sides particles are absorbed by the lead, and we are applying the electric field and magnetic field simultaneously. Simultaneously, we use the electric field and magnetic field. Electric field is this along with the plane, and the perpendicular plane, that is X shows that there is a magnetic field perpendicular to the plane. Experimenters observed that, see, this is a very strong electric field and magnetic field applied to this, and this alpha particle, it has the high mass and low velocity, therefore it shows the larger deflection, to the photographic plate from the, and it is diverted towards the negative. It shows that alpha particle must be positive charge. Second thing, there is a beta particle which shows the minimum deflection as compared to alpha particle because of high speed which is greater than the alpha particle, and it is diverted towards the positive plate. It shows that beta must be negative. Second thing, gamma, it doesn't show the any deflection towards positive negative plate, not to the magnetic field, and therefore it shows the directly incident on the photographic plate in a straight line. And therefore some properties are mentioned here, that is the alpha particle is positive charge, beta is negative charge, beta particle has the 100 times greater than the alpha particle penetration power. Penetration power is the ability of particle to penetrate in the material, or you can say that the metal or any other material. And the beta particle has the high velocity, therefore it is 100 times greater than the alpha particle. Alpha particle has mass more, low velocity, it causes low penetration power, and therefore due to the low penetration power it has the high ionizing power. Alpha particle has the ionizing power is more, but penetrating power is low, and it affects both alpha, beta, gamma, affect the photographic plate. And gamma rays not deflected by electric field and magnetic field, it's directly incident on the photographic plate. There are the two types of radioactivity, natural radioactivity and artificial radioactivity. Natural radioactivity phenomena is studied by the Marie Curie and Pierre Curie, and they discovered the two elements polonium radium, and Marie Curie got the Nobel Prize in 1903 and 1911 respect to the chemistry and physics for the discovery of the elements as well as for the radioactivity phenomena. And her daughter and her son and son-in-law got the Nobel Prize for the artificial radioactivity. Marie Curie Pierre Curie got the Nobel Prize for the natural radioactivity phenomena of the radioactivity and determination of the elements. Her daughter and son-in-law got the Nobel Prize for the radioactivity. Therefore, the Marie Curie is the family who secured the 5 times Nobel Prize, or we can say the 5 Nobel Prize for this radioactivity phenomena. Natural radioactivity. Natural radioactivity is the spontaneous phenomenon of emission of alpha, beta, gamma or radiating particles. Spontaneous phenomenon is important. It is spontaneous means natural, and therefore there are the two types of radioactive material. Generally, uranium, thorium, radium, higher elements whose atomic number is very high. It shows that there is the radioactive phenomena because of nucleus is unstable. And why this is nucleus is unstable? Because of the neutron very high. There are some radioactivity series. which shows that how these series are uh, take part in the radioactivity. How these are the series disintegrate with respect to the uh, number. These are the phenomena. Uranium series. The material has the atomic number. For example, lead 206. 206 is the integral multiple of 4n plus 2, just like 204 plus 2. This shows that n is nearly in such a way that number can be represented in terms of the multiple of 4 plus 2, and this series shows that the disintegration of uranium with respect to uranium disintegrate and leads to the stable nucleus lead. How this takes place? Uranium disintegrates into the thorium, thorium disintegrates into the uranium 234, uranium 238 to 234, then 230, 239 it comes to the next uh, layer 214. Sometimes if there is some emission of the gamma rays, again it comes to the bismuth and so on. This is the series which shows that the radiation takes place in the same series of the 4n plus 2. There is the actinium series. Actinium series shows that there is the nucleus forms in the disintegration time, which are the which are the atomic number having 4 atomic mass number in the range of 4n plus 3. See, 235 plus 3. 232 plus 3 means 235. These are 231 shows the 228 plus 3 in such a way that this can be represented in terms of the 4n plus 3. This is series of actinium which lead to the stable nucleus lead. Same way in the thorium, again there is a thorium series. Thorium series start from 232 thorium. It again convert the disintegrate in the form of atomic mass number of 4n. See that 232 integral multiple of 4, integral multiple of 4, integral multiple of 4. This shows that there is the formation of a stable nucleus lead, lead in a sense of 4n. Next one is the Neptune series, which also shows that the 4n plus 1. This is 241 plus 1. Plutonium, thorium, corresponding all the radium and radion or other things laid and leads to the stable nucleus bismuth also. These are the series which takes place in the radioactive, and these are the stable um, just like a mass of the 4n, 4n plus 1, 4n plus 2 and 4n plus 3 corresponding the mass number, corresponding series are there, and the parent nucleus are there, and corresponding half-life period. Half-life period means the time required to disintegrate the half of its original element. Just like consider that if some material has there is the 100 elements are there initially, and time required to disintegrate into half means 50 elements. The time required is, see that this is a very huge time, and which is very huge time of the material, and this is the stable nucleus produced in this radioactive series. Artificial radioactivity, just like in Rutherford experiment, he performed the artificial radioactivity when the nitrogen 714 incident alpha radiation it converts into the unstable nucleus, or you can say that compound nucleus fluorine, and which is another disintegration takes place and formation of the oxygen and hydrogen. This is the example of the artificial radioactivity in which when we are incident the high radiation particle alpha particle incident on the nitrogen, it combine together and form the nucleus of the fluorine which is unstable, and which is again disintegrate and form the product as the oxygen and hydrogen. This is one of the example of the artificial radioactivity. These are some examples of artificial radioactivity which form in the laboratory. Radioactive decay. Generally, when nucleus is unstable, it forms its spontaneous radiation and it transforms the one nucleus to another, and their radiations are alpha, beta, gamma particles. For example, what happens when the alpha particle emitted from the unstable nucleus? Consider this is X. Z is the number of proton, A is the atomic mass number. When the alpha particle is emitted from this X material, it reduces its atomic number by 2 and atomic mass number reduced by 4 because this is the structure of the helium. This all the reactions are takes place with respect to nucleus, not the chemical compound. We are going to discuss on the basis of the nucleus, not to the electron configuration or you can say the element. We are going to discuss this phenomena with respect to nucleus. What happens when alpha particle disintegrate from the material? It reduces the atomic number by 2 and mass number by 4. Second, these are the some example. Radium. Radium is converted to radon with emitting the alpha particle. Polonium reduced to lead by emitting the helium. Beta decay. When beta decay takes place in the nucleus, it increases the atomic number by 1 and atomic mass number remains the constant or remains or not changed. Therefore, it shows that the example of thorium 90 to 34 when beta disintegration takes place, atomic number increased by 1 and it come to the 91 to 34 and form the one of the beta emitted from the reaction, just like this carbon and other things. As the gamma particle emitted from the material, there is no change in the material, therefore we are not going to discuss about the nuclear reaction. These are the broadly differentiation of the alpha, beta, gamma radiation. Nature, nature alpha particle is nearly equal to the helium nucleus or analogous to the helium nucleus, look like a helium nucleus. Beta particle is faster moving electrons, just like negative charge particle electrons, and gamma is like a electromagnetic radiations. You can say that photons. About the charge, we can say the alpha particle, there is a positive charge, where the beta particle is negative charge. Gamma not deflected means no charge is on it. Magnetic charge also given 3.2. Why it is 3.2? Because there is a 2 in electron. Therefore, 3.2 into 10 raised to minus 9 coulomb. Electron 1.6 into 10 raised to minus coulomb. Gamma has no charge, therefore it is 0. Mass, it is also mentioned here. These are the various parameters we discuss here regarding that. This is the range. Alpha particle has the high mass, therefore it has the very few very high range, but as compared to the beta and gamma, it is less one. Where the penetration power is minimum for alpha particle because it has a heavy mass and therefore its speed also less, but its speed is 100 times more, therefore its penetration power is also more. And gamma rays has the high speed, therefore its penetration power is very high. Ionizing power takes place because of the interaction of the alpha particle. Alpha particle interact more with the material, therefore it has the maximum ionizing power. Beta particle has the high speed, 100 times than the alpha, therefore less interaction and it leads to the less ionizing power. Where the gamma particle has the 1000 times the speed of the alpha particle, therefore gamma rays minimum interaction with the material causing the least ionizing power. These are the one of the derivation regarding the law of radioactive disintegration. The law of radioactive disintegration shows that the rate of change of number of particles or the disintegration of the number of particles is directly proportional to the number of particles present at the initial, and where n is what number of particles at the initial. And what is the law of radioactivity? The rate of disintegration of the radioactive substance at any instant is directly proportional to the number of atoms present at that instant. the rate of disintegration of the radioactive substance at any instant is directly proportional to the number of atoms present at that instant. This is known as the statistical law of radioactivity. This shows that if n be the number of particles, then there is the t with the time, and dn is the number of particles disintegrate in time dt. Then rate of disintegration is directly proportional to the number of particles present at that time, and dn by dt is equal to minus lambda by n, where lambda is the radioactivity constant, and negative sign shows that the as the time increases or rate of disintegration decreases the number of atoms present at that time. Negative sign shows that number of atoms of radioactive element decreases with respect to time. Now we are just taking n to the left side and dt to the right side, then we can get dn by n is equal to minus lambda by dt. You can say that the separation variable we are takes place. After that we are taking the integration. On integration, dn by n is going to natural log. You can say that log to the base e, or you can say that natural log is equal to lambda t plus k. This k is constant, but this is the undetermined constant. Therefore we want to find out this unknown variable. We are taking the initial condition. What is that initial condition? We are taking n is equal to n0. Then when n is equal to n0, t is equal to 0. This leads to the k is equal to log en, or you can consider log to the base en0. We are substituting the value here, and we can simplify this. We can get n is equal to n0 e raised to minus lambda t. Means number of particles at any time is exponentially depends on the initial number of particles. This takes place as the n is equal to n0 raised to minus lambda t. See, this is the n at initial t equal to 0. But after that, as the time increases, it decreases gradually. But remember that this line never touches to the x-axis. Time is infinite, required to disintegrate the total number of particles. Half-life period. Half-life period is the time required to disintegrate the number of particles half of its initial material, and that is known as a tau, or you can tau. You can call it a Latin word alphabet, that is tau. The time required to disintegrate its one half of its original atoms, and according to time we can express this in terms of t is equal to tau, then a is equal to n0 by 2, where n is the number of particle remains. How much? This is the n0 by 2. We are substituting these two values in the earlier equation, then we can say that n is equal to n0 e raised to minus lambda t. Substituting the value n0 by 2, we are substituting the value of n as n0 by 2, and remaining this equation n0 n0 get cancelled. On simplification we can write it as a tau is equal to 0.693 by lambda. Means half-life period of the material depends on the decay constant. Means different half-life period, different decay constant. This diagram shows that as the half-life period is more, then decay constant is less, and according to that, if the half-life period is more, half-life period is more, corresponding decay constant also more. Half-life period is less, decay constant also less. This diagram shows this. Average life period. Actually, what happened generally, there are the different lifetime of the materials, and therefore the average life period of equal to the algebraic sum of all possible lifetimes divided by the total number of atoms present in the beginning. Generally, different materials are different lifetimes, and we get the various materials during the disintegration. Some materials have the short half-life, some materials have the longer life, and therefore we are taking the average life period as the tau is equal to sum of the life period of all atoms divided by total number of present initially, and this is nothing but 0.693 lambda. Average life period of the radioactive material is always inversely proportional to the decay constant, and therefore the half-life period is more for the shorter lives. Lastly, I am very thankful to the Principal J. Thakur sir, under whose motivation we try to develop the ICT teaching tools, and my colleagues Dr. Paresh Gaikar and Ms. Ankita Angre, who's helped me a lot to prepare this presentation and this topic. I am here thanks to all, and the references for this presentation, I use the textbook of the FIBS SIT publication and some internet websites like Wikipedia. And lastly, I thank you to all. Any question, please mention.